Hello, friends. Welcome back to my channel, Scientific Study. I'm Arpan, again with you to talk about wonderful things. Let's begin. Imagine a computer that can solve problems in seconds that would take today's most powerful supercomputers thousands of years. A computer that can unlock new medicines, improve artificial intelligence, and even predict the future of the universe. This may sound like science fiction, but with quantum computing, it could become a reality. For years, traditional computers have been improving, helping us with everything from browsing the internet to building advanced AI. But as problems become more complex, classical computers struggle to keep up. This is why companies like Google, IBM, and Microsoft are racing to build powerful quantum computers that could change the world. In 2019, Google's Sycamore quantum processor made history by solving a problem in 200 seconds that would have taken a regular supercomputer 10,000 years. IBM has also been making progress with its quantum processors, increasing their power every year. Now, Microsoft has entered the competition with a brand new breakthrough, the Majorana 1 chip. This chip could make quantum computers more stable and powerful than ever before. So, what exactly is the Majorana 1 chip? How does it work? And why is it so important? Let's find out. To understand Microsoft's new chip, we first need to know how quantum computers work. Regular computers use bits, which are like tiny switches that can be either 0 or 1. Everything from websites to video games is made using combinations of these ones and zeros. But quantum computers use something much more advanced: qubits. Qubits are special because they follow the strange rules of quantum physics. They have two amazing properties that make them much more powerful than regular bits. 1. Superposition. A qubit can be 0, 1, or both at the same time. This allows quantum computers to perform many calculations at once, making them incredibly fast. 2. Entanglement. When two qubits become entangled, they stay connected even if they are far apart. This means changes in one qubit instantly affect the other, leading to faster and more powerful computing. These abilities allow quantum computers to solve problems that are impossible for regular computers. They could help us develop new medicines, create stronger encryption for cybersecurity, and even model the universe in ways we never imagined. But there is one big problem. Qubits are very unstable. Even the smallest interference, like heat or electrical noise, can cause them to make mistakes. That's where Microsoft's Majorana 1 chip comes in. Microsoft's Majorana 1 chip is a huge step forward because it uses a new type of qubit called a topological qubit. This qubit is much more stable and less likely to make errors compared to regular qubits. The secret behind this stability is something called Majorana zero modes. These are special particles that act as their own antiparticles, meaning they naturally resist outside interference. This makes them perfect for quantum computing because they reduce errors and improve performance. Another big advantage of the Majorana 1 chip is scalability. Most quantum processors today struggle to handle more than a few hundred qubits before they become unstable. Microsoft believes that with its topological qubits, quantum computers could eventually reach 1,000,000 qubits on a single chip. This could be the breakthrough needed to make quantum computing practical for real-world use. So why is this important? If quantum computers become powerful and stable enough, they could change the world in many ways. One of the biggest impacts would be in cybersecurity. Right now, most online security systems rely on complex encryption that regular computers can't break. But a powerful quantum computer could crack these encryptions in seconds, making current security methods useless. However, quantum computers could also create new types of encryption that are completely unbreakable, making the internet safer than ever. Quantum computing could also revolutionize artificial intelligence. Right now, training AI models takes a lot of time and computing power. Quantum computers could train AI models in hours instead of months, leading to smarter and more advanced AI systems. In medicine, quantum computers could help scientists design new drugs and treatments by simulating molecules in ways that are impossible with today's technology. This could lead to breakthroughs in curing diseases like cancer, Alzheimer's, and many more. Beyond AI and medicine, quantum computing could improve climate modeling, financial forecasting, and even space exploration. It could help us predict weather patterns more accurately, make better financial decisions, and solve some of the biggest mysteries of the universe. Even though the Majorana 1 chip is a big breakthrough, quantum computing still has challenges to overcome before it becomes part of everyday life. One major issue is temperature. Quantum processors, including Microsoft's new chip, need to be kept at temperatures close to absolute zero minus 273 degrees Celsius to function. This makes them difficult and expensive to operate outside of specialized labs. Another challenge is error correction. While topological qubits are more stable than regular qubits, quantum computers still need complex error correction systems to make them reliable. Without proper error correction, quantum processors can lose information too quickly to be useful. Despite these challenges, Microsoft's Majorana 1 chip is a huge step forward. If they succeed in making quantum processors with 1,000,000 qubits, we could see the first practical quantum computers within the next 5 to 10 years. This would completely change technology, science, and even daily life. Quantum computing is no longer just an idea. It's happening right now. Microsoft's Majorana 1 chip could be the breakthrough that finally makes quantum computers powerful, stable, and scalable. If successful, it could change everything from cybersecurity to medicine and artificial intelligence. But what do you think? Do you believe quantum computers will replace regular ones in the near future? Or do you think we're still a long way from seeing them in action? Let me know your thoughts in the comments. If you found this video interesting and want to stay updated on the latest tech innovations, don't forget to like, subscribe, and hit the bell icon. Thanks for watching, and I'll see you in the next one.